Welcome to the review day for your last test of the year on circles. So before we get looking at worksheet 13, I wanted to do just a couple of questions from worksheet 12, just so we hit a little bit of everything before you take your test tomorrow. Worksheet 12 should be in your optional review worksheet folder in Schoology. If you don't want to open it, no problem, just follow along. It shouldn't take too long. Okay, so I just want to look at a couple of ones, starting with number 3. So number 3 is an interesting one because it's not super obvious exactly which formula we're going to use just by looking at it. We kind of have to think a little bit of what's going on in the diagram. So let's look at that. X is what we want to solve for. It is a half of this chord. Now we know it is half of the chord because this diameter is perpendicular to the chord. And when a diameter is perpendicular to a chord, it bisects the chord. So we know that's going on. We also see that this segment here is a radius. It starts at the center, goes to the point on the circle, and the radius is 10. That means all the radii in the circle are 10. So this is a radius, and this will be 10. So this whole blue segment is 10 units. So if this part is 4, this part is 6, so the whole thing is 10. And if we draw in our own radius, any radius we draw in would also be 10 units. So we want to be strategic about where we draw the radius in. If we draw it here, we create a right triangle with that unit that's 6, and then this missing segment length that is x, and the hypotenuse is 10. This is a 6, 8, 10 right triangle. So we kind of just put a bunch of information together to figure that one out. Okay? Versus number 4, this one should hopefully be a little bit more straightforward. We have 2 segments. They both happen to be secants. So we're going to use our secant formula, which tells us to take the outside part of the secant times the whole thing and set that equal to the outside part of the other secant times the whole thing. So in this case, the outside part is 9. The whole secant, 9 plus 12 is 21, is equal to the other outside part, 8, times the whole secant, x plus 8. And then we're just going to multiply and distribute and all that good stuff. So we'll multiply 9 times 21 is 189 equal to 8x plus 64. Distribute that 8. And then we just solve for x. Here, when we divide both sides by 8, it's a decimal. We don't want decimals. Exact answers are always better. So we'll just leave it as an improper fraction there. X equals 125 over 8. So a little bit more straightforward of secant. All right, moving right along, let's take a look at number 10. So again, a lot going on in the diagram. Let's see what they give us. They start us off by saying that MN is congruent to PQ. So MN is this chord, PQ is this chord. So when 2 chords are congruent, that means they have to be the same distance away from the center. So OR and OS must also be congruent. So we can set these equal to each other and say 4x minus 5 is equal to 2x plus 7. And solve and get that x equals 6. Now that we know that x is 6, we can plug it into and find the actual length. So they tell us that PQ, this chord here, is 7x, or 7 times 6, which is 42, which brings us right back to the start, that if PQ is 42, well then MN has to be 42. This segment has to be 42 as well because they are congruent. So that means MN is 42 units long. Okay, so again, another theorem that we used here, that if 2 chords are equidistant from the center, then they're congruent, and if 2 chords are congruent, then they're equidistant from the center. So the same theorem, just 2 different directions. All right, and the last one I want to look at is number 16 here, where you're finding the area of a sector and the length of an arc. So remember, these are just fractions of the whole thing. So if they want the area of this sector, they want to know how much pizza we're eating. If we eat this slice of the whole pizza, we need to know what fraction of the pizza we're eating. Well, that comes from the central angle. So it's 90 degrees out of the 360 times pi r squared. So in this case, the radius is 8. So 90 over 360 is a quarter of the whole thing of the 64 pi, and when you multiply through, you get 16 pi, and our units are kilometers, so square kilometers here. Okay, so again, a fraction of the whole thing. And we use the area formula because they wanted the area of the sector. Now it's the same idea with below when they want the length of the arc. They just want this fraction of their circumference. The circumference would be the distance around the whole circle. They don't want the distance around the whole circle. They just want this fraction of the circle. So it is the same 90 over 360. That's our fraction. This time times the circumference, 2 pi r, which is your 16 pi. So a quarter of the 16 gives us 4 pi kilometers. Again, leave your answer in terms of pi. Make sure you have your units, all that good stuff. The last one then is the area of that highlighted segment. So if we go back to the idea of this slice being a slice of pizza, how much crust are we eating? So the segment is like the crust of our pizza. So how much is that? So what we have to do is if you take your slice of pizza and you eat the pizza part, the part with all the toppings, right, you're going to be left with the crust. So what we have to do is find the area of the sector, so the angle over 360 times pi r squared, and then minus the area of a triangle, 1/2 base times height, and that will get us the area of the segment. So in this case, we already figured out what the area of the sector is, right? We did that over here. So I'm just going to plug in 16 pi. We did that work already. Now we have to find the area of this triangle. So remember, all radii are congruent. So if that's 8 kilometers, this is 8 kilometers. And the base and the height must always be perpendicular, right? So in this case, the base and the height of the triangle are the 2 radii. So it's going to be 1/2 8 times 8, which gets us 32. And so put that all together, the area of the segment is 16 pi minus 32 square kilometers. Okay, so knowing how to find the area of a segment, the area of a sector, and then the length of an arc, those are 3 really important ideas. So I definitely wanted to make sure we touched on those. All right, nice. So those are the problems from worksheet 12 that I thought were good, just to make sure we touch on a little bit of everything before you take your test. Now let's go ahead and take a look at worksheet 13.